something mysterious near the Milky Way galaxy galactic center is flashing radio signals. What are these signals? As our eyes are on the skies and they grow even more sensitive, we're going to find more and more things we've never seen before. This is the case for a newly discovered source of radio signals located not far from the center of our galaxy, the Milky Way galaxy, of course. Is called ASCAP J173608.2-361-635, and astronomers have been unable to figure out what kind of cosmic object best fits its weird properties. The paper has been accepted for publication in the Astrophysical Journal, available on preprint server RXIV. The team of astronomers led by Zhe-Ting Wang of the University of Sydney in Australia said, "We have presented the discovery and characterization of ASCAP J173608.2. ASCAP J173608.2 may represent part of a new class of objects being discovered through radio imaging surveys," he said. ASCAP J173608.2 was discovered using the Australian Square Kilometre Array Pathfinder, ASCAP for short, one of the most sensitive radio telescopes ever built, and is designed to peer into the radio universe. Kindly support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. It's already proven adept in finding things that we've never seen before, such as odd radio circles. We don't know what those are yet. Undiscovered galaxies, and mysterious fast radio bursts, like the one we're talking about here. ASCAP might turn out to be an unknown type of cosmic object, but if it does, it could end up the stretch and definition of whatever object that is. It could stretch the definition. It's highly variable, emitting radio waves for weeks at a time, and then disappearing on rapid timescales. The signal is also highly polarized, that is, the orientation of the oscillation electromagnetic wave is twisted, both linearly and circularly. ASCAP is also quite a tricky beast to spot. The object, whatever this is, had not been seen before the ASCAP detections made during a pilot survey of the sky to look for transient radio sources. Between April 2019 and August 2020, the signal appeared in the data 13 times, so it was not by coincidence. Now, follow-up observations in April and July of 2020, using a different radio telescope, the Murray-Yang in Parkes, Australia, yielded nothing, but the Meerkat radio telescope in South Africa got a hit in February 2021. The Australia Telescope Compact Array, ATCAP, also made a detection in April 2021. So this was caught by various types of telescopes. Now this supports and validates the ASCAP detections, but also suggests that the source is quite elusive. There were no Meerkat or ATCAT detections prior to that date, nor did the source appear in X-ray and near-infrared observations, nor in archives of radio data collected by multiple instruments in the researchers that the researchers checked, which leaves a pretty fascinating mystery. The polarization suggests scattering and magnetization, possibly partially due to dust and magnetic fields in the interstellar medium between us and the source, although it's possible that the source itself is also highly magnetized. All up, it's really hard to figure out what the source might be. There are several types of stars that are known to vary in radio wavelengths, such as stars that flare frequently, or close binaries with active chromospheres, or that eclipse each other. The non-detection in X-ray and near-infrared wavelengths makes this unlikely, though. Flaring stars usually have X-ray emission that correspond to the radio emission, and the vast majority of stars have ratios of near-infrared emissions that should be detectable. Nor is a polarized a pulsar likely, the type of neutron star with sweeping beams of radio light like a cosmic lighthouse. Pulsars have a regular periodicity on a time scale of hours, and ASCAP was detected fading, which is inconsistent with pulsars. So it can't be a pulsar. Also, there was a 3-month span with no detections, which is also inconsistent with pulsars. X-ray binaries, gamma-ray bursts, and supernova were also all ruled out. But the object does not share some properties with the type of mysterious signal spotting near the galactic center. These are known as galactic center radio transients, or GCRT, 3 of which were identified in the 2000s and more of which are awaiting confirmation. These sources are also yet to be explained, but they have several features in common with ASCAP. If ASCAP's detection could help us find more such sources of figures and figure out what they are, given that ASCAP J173608.2 is typically not detected and can turn off on timescales from several weeks to as quickly as a day, our sparse sampling, that's 12 epochs over 16 months, suggests that there could be other similar sources in these fields, the researchers write. They say increasing the survey cadence and comparing the results of this search to other regions will, of course, help us understand how truly unique ASCAP J173608.2 is and whether it is related to the galactic plane, which should ultimately help us deduce its nature. So do you see how many things they're finding out with all these new telescopes all the time, and new questions are arising? So this is still a mystery. What's coming out, these fast radio signals from our galactic center? This was published on Astrophysical Journal, and it's on Science Alert. Please leave your comments. Thank you for your support.